All right, guys, I'm just gonna real quick walk you through one of these problems just to make sure you're ready to go for the quiz. So this will be pretty quick, and you've seen it before. This is what we did yesterday, but I just want you to have a fresh sample in your head before you do this on the quiz. So first thing, remember whatever it is that's being taken to a power, that is your growth or decay factor. If it is growth, that number is greater than 1. If it's decay, it's a number between 0 and 1, okay? I'll write this like that. X is greater than 1 if it's growth. If it's between 0 and 1, so a fraction between 0 and 1, then it would be decay. So this one would be decay. Right? Remember, your domain is always going to be all real numbers. We're going to plug in -2, -1, 0, 1, and 2 to get an idea of what this graph looks like. Remember, if there's nothing back here, no plus something, minus something, then your asymptote should be at 0. But you'll see that when you graph these numbers. So let's plug it in. You're going to get your calculator and go 1/2, put that in parentheses. If you don't put it in parentheses, you're going to get the wrong answers. So as you plug it into your calculator, plug in 1/2 to the -2nd power. If you plug that in, you should see you get the number 4. Remember, you're also welcome to flip that over and take it to the positive power, which also gets you 4. But feel free to plug into your calculator. Second one is going to be 1/2 to the -1st power. Remember, you can just arrow up and change that -2 to a -1. You don't have to retype in the whole thing. And you get a 2 from that. 1/2 to the 0 power. Remember, anything to the 0 power is always 1. 1/2 to the 1st power is going to be 1/2, or you may write it as 0.5. And then 1/2 to the 2nd power. Again, you're welcome to plug all of these into your calculator, but that would come out to 1/4 or 0.25 if you like that better. Okay, so then we're going to plot those points. -2, 4. 1, 2, 3, 4 is right there. -1, 2 is right here. 0, 1, that's where we hit our y-axis. 1, 1/2, and maybe you want to zoom in a little. So 1, 1/2 is at 1, so it's going to be somewhere on this line, right? Because that's our x value being 1. But then we need to go 1/2 of the way up to 1. So it's not quite to 1. Here would be 1. This is 0. We have to go 1/2 of the way up. So 1, 1/2 is right there. And then 2, 1/4. So we go 1/4 of the way up to 1. Looks like that. And then you can see your curve is going like this. Makes sense that this is decay now, right? Because it's on its way down. Your range then is what are your potential y values. So your y will have to be greater than what number? Tell your neighbor. Did you say 0? Remember, when there's nothing behind here, that's like saying plus 0. That's going to be where your asymptote falls. And then your y-intercept is always this guy. So it's the point 0, 1. It's whatever you get when you plug in 0 for x. So 0, 1. And then your asymptote is the same as your range, but it's an equation. Y equals that number. So y equals 0. Okay, so you'll have to do that on the quiz. And then you'll also have to do this on the quiz. And remember, I gave you 2 equations yesterday. One for growth, that has a plus. One for decay, that has a minus. Okay, so we'll just do one of the, actually, I'm going to talk about both of these real fast. So your equation should look like this or this, but with numbers in this spot, and that spot. Okay, so your y is going to stay put, but everything else should change. Same thing over here. A, R, and T should all have numbers in place. So if I'm going to write this equation, it says about 60 southern sea otters had an annual growth of 16%. Use an exponential function. Now, this one is specific, right? The more generic function won't put a number here for t because we want to be able to see after how many years is there. So if you put the 6 in, fine. If you don't put the 6 in your equation, probably even better, but eventually you're going to put the 6 in. So this equation would be y equals, remember A is your starting amount, so that's 60, and then it's 1 plus, think about how you write 16% as a rate, as a decimal. So if it's 16%, your decimal point is here. A percent means we divide by 100. So that's going to move us 2 places to the left. So this is 0.16 to the t power. If you put a 6 there, because that's the number we want, that's fine. I will take it. If you put a t there, I will take it. Because this would say this is the equation we're going to use for any number of years. I specifically want 6 years, so you would plug in a 6 right there. 60 times, you may write it as 1.16 if you want, or you may leave it as 1 plus 0.16. That's fine too. This is what you would plug into your calculator to get that number, okay? It's growth, right? So we used the growth equation. This one says population is decreasing, so that's going to be decay. So that's this guy. So we say y equals the starting amount, 8,500, times 1 minus your decay factor. 7% has a decimal right here. If you are turning it into a decimal, not the percent, then you have to divide by 100, 1, 2, which means, this is what everyone does wrong, you got to drop a 0 in, okay? So 0.07 to the t power. Again, if you would like to write that as 8,500 times 0.93 to the t power, that's great too. Or you may just leave it like that. So the population in 10 years, you're going to take that 10 and you're going to drop it in right there and you'll get your population. Okay, you would just plug that into your calculator. All right. This is essentially what your quiz looks like. Some graphing, some population growth and population decay, or exponential growth, exponential decay. It's not necessarily population. But hopefully you feel well prepared and do a great job. Have a great weekend.